Hey everyone, welcome to StackOps AI. In today's video, we are deploying a Hugging Face model on AWS SageMaker using the AWS CDK in Python. We'll take a small pre-trained NLP model from Hugging Face. It's called the Distill BERT Sentiment Classifier and turn it into a live inference endpoint on SageMaker. So you can send text to it and get back predictions instantly. By the end of this video, you will know how to deploy any Hugging Face model to SageMaker using CDK and understand exactly what's happening under the hood. Okay, so the model we are using today is called Distill BERT Base Uncased Fine-Tuned SST to English. It's a text classification model, as you can see on Hugging Face website. It's a lightweight version of BERT, trained for specifically for sentiment analysis. Basically, it can tell if a sentence is positive or negative. For example, if you pass something like, I love AWS SageMaker, it should return whether it's a positive or a negative sentiment. So it's a very small, super fast, and perfect for demos or microservices. That's one of the reasons I chose this for this demo. I have shared the link of Hugging Face model in the description in case you want to explore more. You can take a look. Before jumping into the code, let's talk about how a Hugging Face BERT model can be deployed on SageMaker using CDK. So on left-hand side, this is our local machine. We write CDK code in Python, which defines all the AWS resources we will need, like the IAM role, SageMaker model, and endpoint configuration. Once our code is ready, we use CDK synth command to generate a CloudFormation template. Next, that CloudFormation template is deployed into AWS Cloud using CDK deploy command. SageMaker then download BERT model directly from Hugging Face Hub using the environment variables that we will define, such as HF model ID, HF task. You would know more once we start diving into it. Once the model files are downloaded, SageMaker builds a SageMaker model object. This represents the deployed version of our Hugging Face model inside AWS. After that, SageMaker creates a real-time inference endpoint. This endpoint acts like an API. It's where we will send our text input for predictions. On the right-hand side, under inference, we have Python script that invokes the SageMaker endpoint. In real projects, we configure something like API gateway, Lambda, ECS, etc. to invoke this endpoint. But for the purpose of this demo, I have created a small Python script to invoke it. The script sends a small JSON payload containing the text. For example, I love using AWS CDK with SageMaker. The endpoint responds instantly with a prediction, something like label, which says whether it's a positive or a negative sentiment, with a score of, for example, 0 point something, whatever the confidence score is. So this completes end-to-end pipeline from writing CDK code locally to getting real-time NLP prediction in AWS. Okay, let's start a clean project and deploy. So I'm making a directory named deploy LLM to AWS and cd to deploy LLM to AWS. Yeah, and now I'm going to first check what's the version of CDK on my computer. Yep, it's 2 point something. CDK 2 is good. I'm initializing a new CDK project in Python. Yeah. Okay, and I'm going to create a virtual environment and install all the dependencies. So starting with Python 3 and source, activating my virtual environment. And do we have a requirement? Yep. So I just install all the dependencies. Yeah, looks good. Now that the skeleton CDK project has been set up, we'll first take a look at app.py. App.py serves as the entry point for your CDK application. It's where you define and instantiate your CDK constructs and stacks, which ultimately orchestrate the deployment of your AWS infrastructure. You can instantiate as many CDK stacks as you want, but in our case, we are going to have only one stack, which is defined in this class. The class is coming from deploy, this folder. If you go into this class, this file, you would see there is a definition, which is empty for now. We'll fill it later, but we are going to only refer to it for now in this app.py. We don't have to make any changes here except adding the environment. So CDK needs to know which AWS account you are going to deploy in and what's the default region, which are coming from these environment variables. I have already set these up. Let's move on to the main stack, where we define the IAM role, SageMaker model, and endpoint configurations. At the top, we have a bunch of imports. We import the CDK modules and construct a library in this way. Basically, we are going to create IAM role and SageMaker, so we need to import those modules, AWS SageMaker as SageMaker. Next, we will define some few constants that we need for our demo. These are HF model ID that points to our Hugging Face model. As mentioned before, it's a BERT model. HF task is the model's task. It's a text classification, which we have seen on Hugging Face website itself. The instance type is a very cost-effective CPU instance for this demo. We then define a helper function that returns the correct Hugging Face container image hosted on AWS ECR. That's the function. It has an account ID, tag, and it returns ECR URI. It's the image that actually runs our model in SageMaker. So let's talk about this ECR container image a bit more to understand where this container image is coming from. Basically, SageMaker doesn't run models. It runs them inside containers. For Hugging Face models, AWS provides ready-made deep learning containers, DLCs, hosted in this AWS account. You don't upload them or build them yourself. You just reference them via their ECR URI pattern, which is this. So this is a DLC account, which is always going to be the same. The region is your region where you are running your services. The repo is going to be the same for Hugging Face repository, and there is a tag. So we'll talk a bit more about tag, but this is the basic structure of the ECR URI. Let's understand the tag a bit more. So 2.6.0 is the DLC framework bundle version. It is by AWS to often tracks PyTorch version or OS update versions, etc. The next part is Transformers 4.51.3. This is the Hugging Face Transformers library version used to build this image. Next is CPU or GPU. Whether the image supports CPU or GPU. If it is CPU, that's fine. If it is using GPU, it expects another bit here, which is called CUDA. It's a parallel processing system. So in our case, it's a CPU image. The next bit is the Python version that this image is used to build. So it's 3.12 in our case. The next bit is Ubuntu 2204, which is the base OS. So rule of thumb is that if your instance type is CPU, you will use CPU tag, and if your instance type is GPU, you would use GPU tag. Now let's look at our main CDK class. This is where we define the stack that holds all of our AWS resources. So we'll first grab AWS region from the CDK environment because we'll use it in our image URI, which is the way, this is the way we get it. Next, we'll create an IAM role. This is my code here. This role allows SageMaker to perform actions like pulling model images and creating endpoints. You can see that I have set up the trust principal to SageMaker Amazon AWS.com. And for the simplicity, in this demo, we attach AWS managed policy, which is the Amazon SageMaker full access. In production, usually we would tighten this with custom permissions. We define environment variables. These are key value pairs that we pass to the container at runtime. Here we tell the container which model to download from Hugging Face and what task it performs. The Hugging Face inference container automatically handles model download, caching, and serving when it sees these variables. So these are the ones. Here you go. We then create a container definition property that tells SageMaker which image to use, what mode, and what are the environment variables. So this is the way we define it. So we are passing the image that we get from our function, and the mode is single model. So this mode option specifies how the model container interacts with the model data. There are two modes. One is single mode, which is what we are using, and there is another mode called multi-model. In single model option, the container is designed to host a single model, which is what we are doing here. Whereas a multi-model mode is used when you want to run multiple models in a single container. We create a SageMaker model resource represented by CFN model. So this ties together the container definition and the IAM role. When the CloudFormation runs, SageMaker will automatically download the model from Hugging Face Hub and prepare it for inference. Then defined a production variant that specifies how many instances to start with, what are their instance types, and which model they are serving, and how the traffic will be served. So this is how we define it. Sorry, just remove this part. We are starting with the one instance, and this is the instance type coming from the constant we defined earlier. We have the model name, and this is how we are creating the endpoint configuration. This should be SageMaker. This is our endpoint configuration with this production variant. Finally, we create a SageMaker endpoint itself. This is the live HTTPS endpoint you can send your inference requests to. So that's how we define it with CFN endpoint. We are giving it a name, and then the configuration is pointing to this configuration defined here. We give it a well-defined name so you can identify it. Once deployed, this endpoint will host our Hugging Face BERT model and respond to the real-time inferences. In the end, we will add a few outputs that we want to see on our CloudFormation output section to easily access the details of it. All right, I'm going to run CDK synth command here, which will now synthesize our CloudFormation stack. Behind the scenes, CDK has converted our Python code into a CloudFormation template. You would see that it should generate a cdk.out folder here, and there would be a CloudFormation template with the definition of the resources. You can see there is a model, the primary container, the endpoint configuration, and everything else that we defined in our Python code. Now I'm going to run CDK deploy command. This should usually take a few minutes because SageMaker is now going to pull the Hugging Face inference container image and download the BERT model weights from the Hugging Face hub. So this should take at least 5 to 10 minutes. So I'm going to pause this video here and come back after it finished the deploy. Okay, so now CDK has provisioned all the resources. Now we are going to test our endpoint from Python. As I said earlier, I have created a small script called invoke endpoint.py. This is a script that is using Boto3, the AWS CDK for Python, to call the SageMaker runtime API. It sends a small payload containing the input, which in our case is I love using SageMaker with Hugging Face. And the prediction, we should receive a prediction directly from the endpoint. So let's try that. To run this script, we need to set up the endpoint name for the environment variable. So I'm going to export endpoint name, and the name is this. And then we run this script and invoke. Okay, so it has responded with a label and a confidence score. That means it's correctly identified that our input expresses a positive emotion with a very high confidence score. So under the hood, SageMaker is using Hugging Face Inference Toolkit, which automatically load the BERT model from Hugging Face Hub. It then runs our text through the model, return the prediction over HTTPS endpoint. Okay, so now that we have tested our endpoint and seen the predictions, please don't forget to clean up your resources to avoid unnecessary charges. So to destroy the resources, we run CDK destroy, which should get a confirmation from you whether you want to destroy them or not. So that's the full workflow. We defined our Hugging Face model with CDK, deployed it via CDK deploy, verified it in AWS CDK, verified it in the SageMaker console, and successfully made a live inference call. With this setup, you can easily swap the model ID to deploy any other NLP or LLM model from Hugging Face. If you enjoyed this video, please don't forget to hit and subscribe, and I'll see you in the next video.